Hello, today's lecture is about drawing layout for various VLSI circuits. But before drawing layout, whatever circuits are given, we should know how to draw its stick diagram. And taking stick diagram as a reference, we can draw the layout easily. So today we will see how to draw stick diagram for a given circuit. And we'll take an example of CMOS inverter circuit. So to draw stick diagram, there are few rules. A color is meant for a particular material. So we will see first which colors are used to draw a stick diagram for VLSI circuits. Now to represent polysilicon, we use red color. So red color line indicates it's polysilicon. This is the width and this is the length of the polysilicon. To draw metal 1 layer is represented by blue in color. So metal 1 layer is represented by light blue. Metal 2 is represented by dark blue. P plus diffusion is represented by yellow color. So P plus diffusion, yellow color is meant for P plus diffusion. Green represents N plus diffusion. To represent well, either it's an N well or a P well, we show a dotted color brown line representing it's a well, which we also call it as a demarcation line. To represent a contact is where two different materials meet, like metal plus P diffusion or metal plus N diffusion. There, where two different materials meet, we represent it by a contact. So contact is shown with a black color dotted circle. Now with all these color representations, how do we prepare a PMOS transistor? PMOS means P plus diffusion. So poly crossing diffusion creates a PMOS transistor. So we have PMOS, which is a P plus diffusion, which is represented by yellow color. That's the diffusion. Poly is represented by red color. So poly crossing diffusion creates a PMOS transistor. Here I have drawn P diffusion horizontally. I could have also shown P diffusion vertically and poly crossing it. So poly is horizontal. So either of the way, poly crossing diffusion is a transistor formation. Similarly NMOS is N-type. N-type diffusion is green in color. So poly crossing diffusion creates NMOS transistor. Either your diffusion is horizontal or your diffusion is vertical. Poly crossing diffusion creates an NMOS transistor. So these are the color rules that you have to use. Now with this as an information, we will go for a second. We'll take a simple circuit and a CMOS inverter, and we will see how to draw its stick diagram. So a CMOS inverter, there is one PMOS transistor, there is one NMOS transistor. Right? Given any transistor circuit, you should know which is the source terminal and which is the drain terminal. So for every circuit, you mention which is the source and which is the drain. So for PMOS, that's the source terminal. For NMOS, that's the source terminal. So source terminal of NMOS is grounded, whereas source terminal of PMOS is connected to VDD. The other left out terminal is a drain. So the other left out terminal is a drain for NMOS and for PMOS. So the first thing you do is, given the transistor circuit, mention where are the source and the drain of all the transistors. So that's the source drain of PMOS, that's the source drain of NMOS. And then you begin with the stick diagram. So first we start with drawing VDD and VSS. These are the metal lines. For metal lines are drawn with blue in color. So you have light blue color to represent your VDD and VSS. So this is your VDD and this is your VSS. Then there is a PMOS transistor. So PMOS transistor is P diffusion. That's a P diffusion. Down one is an NMOS transistor, which is an N diffusion. Now there is a transistor formation. So poly should cross the P diffusion for PMOS. Poly should cross N diffusion for NMOS. Now this becomes your source or this becomes your drain. It is up to you to decide. So let me decide this as a source terminal for PMOS. So let this be my source terminal of PMOS. The other becomes the drain. Similarly for NMOS, let me decide that's the source terminal for NMOS. The other becomes the drain naturally. And now look into the circuit connections. Source of PMOS is connected to VD. So let us connect diffusion to source of PMOS connected to VDD, source of NMOS connected to VSS. Now this is a place where two different materials meet. So that's the contact which is shown black in color. That's the NMOS contact which is shown with metal with a black dot. So these are two connections done. Now next, drain and drain are shorted to each other. So that the drain terminal of PMOS is shorted to drain terminal of NMOS. Again, two different materials meet here. There is a contact. There is a contact. Diffusion and diffusion cannot be directly connected. So that's the contact. Now, so this source drain connection is done. Gate of PMOS is connected to gate of NMOS. Gate is nothing but the polysilicon. So gate of PMOS is connected to gate of NMOS. Now these lines should be straight. Now I am drawing some crooked lines there are, but make sure that it should be a straight line. So drain and drain connection becomes the output, gate becomes the input. So here you have your output, that's a drain connection, and this becomes your input. Poly becomes your input, right? Now either you use a N-well process or you use a P-well process. To represent N-well or P-well, we use brown color, a dotted line which we use to represent well, which is also called as demarcation line. So that's the stick diagram for your inverter. Now with reference to this stick diagram, you will be able to draw layout. Now drawing layout, the layout appears same like your stick diagram. The only difference is these metal lines, this diffusion lines, the dimension of these lines should be according to your layout rules. Thank you.